Students, and welcome to our continuing lesson on how to solve problems using sinusoidal curves. And again, we're working on another word problem here, and which says, on a particular Labor Day, the high tide occurs at 7:12 a.m. At that time, the water was measured to be 11 feet deep. At 1:24 p.m., it is low tide, and the water is only 7 feet deep. Assume the depth of the water is a sinusoidal function of time with a period of half a lunar day, which is about 12 hours 24 minutes. And we have three questions to ask. At what time does the first low tide occur? What was the approximate depth of the water at 4 a.m. and at 9 a.m.? What is the first time that the water is 9 feet deep? Okay. And so there's a whole lot of things going on here. But one of the most important pieces of information that the problem is nice enough to give us is that the depth of the water is a sinusoidal function. And not only that, it gives us the period, which is about 12 hours and 24 minutes. So knowing that, the first thing we're going to, we can answer these three questions really pretty quickly if we know what the function is. And so what we need to do is sort of figure that out. Now, let's take a look here at what all of this means. Actually, I'm going to keep my handout here. And so we're going to define a function, f of t equals, and since it says sinusoidal, it's going to be something sine something, and we need to add some, we do some sort of transformations here. And we need to make a few things clear that t, let's do a unit conversion here. Since we got a bunch of different units like hours and minutes, let's just say this is minutes since midnight. I think that's going to make our lives a lot easier if we can do that. And then f of t is going to be depth of water. Depth of water. And let's make that in feet. Okay, in feet. Since that's some of the units we're given here to work with. So first thing that I'm going to do is just sort of use these 2 points here. High tide, low occurs here at 11 feet. 124, low tide, 7 feet deep. So let's make a quick little table. And again, we are going to convert everything into minutes since midnight. So 7:12 a.m. So this is t, minutes since midnight, and f of t. 7:12 a.m. translates to 432 minutes since midnight. And you can do the math on the side here. This is 7 times 60 minutes per hour plus 12 gives you 432. And the water was 11 feet deep. And then the next time we have here is 1:24 p.m. So that's been 13 hours. 13 hours times 60 minutes plus 12. That is going to give us, plus 24. I don't know why I wrote 12. 24. Okay. 13 times 6 is 780. Plus 24, that's going to give us 804 minutes since midnight. And the water was 7 feet deep at that time. Okay. And what we really need to do and figure out in this function is figure out, well, what's, this is going to be a sine bx plus h plus d. Okay. And we need to find values for a, b, h, and d in order to solve for this function. So now I'm going to set this aside, and we're just going to work solely on this. Oh, I'm sorry. Before I set that aside, one more bit of information is that the period, this is really nice of them to give us this, the period is 12 hours and 24 minutes. 12 hours and 24 minutes. So do 12 times 60, which is 720, plus 24 more. So that's 744. Okay, I'll write this on the side here. 12 times 60 plus 24. That gives us period is 744 44. Okay. We've done this line here to separate my work from the main part of the problem here. So that's the period, and we know that for a sine curve, we can actually use the period here to solve for b. So we know that the period is equal to 2 pi divided by absolute value of b. So we'll just make sure that b is positive here. Substitute this in, 744 equals 2 pi over b. We can solve this equation and we get that b is equal to pi over 372. And I'll show you how this happens on the side here. Multiply both sides by b. 744b equals 2 pi. Divide both sides by 744. b is equal to 2 pi over 744. And then you're going to reduce the top and the bottom. So that gives you pi over 372. Okay, just like what we have here. And so that's one part. That's really, we're going to take this and substitute this in later. Okay. Now, how do we find amplitude? How do we find the amplitude? Well, think about this here. This is high tide. This is low tide. Okay. So that's the max, and this is the min of our function. And we know that the amplitude is equal to A, and also the amplitude is equal to 1/2 max minus min. So from then we can work on this and just say that, well, the amplitude, which is equal to A, this variable here, is equal to 1/2 times 11 minus 7, which gives us 2. So that A equals 2. So we can sort of slowly update this function now. We can say, look, f of t is equal to 2 times the sine of pi over 372, that's the value of b, times x plus h plus d, okay? Plus h and then plus d, but we don't know what h and d are yet. So let's just think about this for a moment here and think about problems before where we said, you know, how do we figure out what to do with this? Well, before we would have a problem like, you know, the sinusoid has to go through certain points, but here it's gotta have a max at 411 and it's gotta have a min at 8047. Okay, so I'll make a note here and I'll make this in a different color to keep things interesting. Okay, we're gonna say that it must have a maximum value at 432.11 and a minimum value at 8047. Okay, that's given in the problem. This 4 here is terrible. 8047. Okay. So let's just graph it and see what we got so far. Okay. So let me go to my grapher here. And let's just see what we got going on so far. Let's go to y equals. Let's just clear out everything in here. And let's graph our function. It's going to be 2 sine quantity. Remember to put in the parentheses, otherwise, you know, the order of operations is going to mess you up. Pi over 372 times x, and we don't know what h and d are yet, so we'll just leave that alone for right now. Okay, and looking at our window, and the window is somehow always a tricky problem for students to do, but we know that the y values, or the vertical values, has to be between 7 and 11, and the x value is going to go up to like 800. So for our window, we're going to go between 0 and let's say 1000, because these, keep in mind, these are minutes since midnight that we're working with here, so they can get pretty big. Okay, and we'll increment it by 100. The y min here represents the height of the waves, which is actually pretty small compared to these numbers. We'll go between 0 and say 20, because we know that at high tide it was only 11, so that's plenty. Actually 20 might be too big. Let me go up to like 15. Okay, we can increment it in ones or in fives or in threes. That's really not a big deal. And let's hit graph. And you can see here, this represents the height of the water. So it starts out low, the water goes up, and then at low tide it comes back down again. Mind here that we must have a max at 432.11. So let's see what our max is at right here. It's going to be way off. Second, calc, maximum. That's the fourth item on the list there. And left bound at 300. No, I want my left bound to be a little bit smaller than that. I want it to be, let's say, like 390. That's too far off. Item on the list, and I'm not gonna try to be too fancy about it. I'm just gonna move and click my cursor here. Every time I click, you can see the red show up. I click really fast, so it produces a bunch of red circles here. It's a little bit of an annoying thing. That's the left bound. Let's find a right bound. And we'll guess the middle here. These are incrementing by 100, so we'll guess it's like 200. $186. And so we're gonna have to really move this point here around a little bit in order to get the maximum to be equal to 432.11. So this is 186 and 2, and we need it to be 432 and 11. Well, let's go back to this problem. We need the max to be at this point, and we've been using sine a lot. If you're in Mr. Wen's class, you've used sine a whole lot. But I'm going to make a note here that because we want the max to be a specific point, okay, it is actually easier to use cosine instead of sine. It is actually easier for us to use cosine instead of sine. So I'm going to take this entire function here and I'm going to rewrite it using the cosine, and you'll see why in a minute. F of t equals 2 cosine pi over 372 x plus something plus something. Okay. And let's go back into our graph, and I can illustrate this point for you. Let's go back to y equals, and all I'm going to do here is really just change sine to cosine and hit graph. And as it's graph, so that makes life a lot easier for us if we don't have to do this calculation in terms of some other number, but we can just do this in 0, 2. Okay? So that's where the maximum point is, 0, 2. So all we need to do is take this point and drag it up to 432.11. So we can just drag this point up to 432.11. Well, to do that, we just need to subtract 432 because it's got to go to the right, 432 units, and go up 11. Okay? And that will give you your answer. So let's see if that in fact works. Just a bit. And you just got to be careful to use parentheses whenever you're doing these problems, just to make sure that the order of operations doesn't mess you up here. Fourth, so we're subtracting 11 to the outside. Use a graph, and you can see this graph starting to generate, and it's going to make quite a bit more sense here. And again, we can do this using the sine function as well, but just using cosine is much simpler for us and a little bit more straightforward, I think, because cosine has a max that occurs at 0 here instead of occurring way at some other point. So we should get 11, and not only that, it should, uh-oh, I think I made a mistake here. Let's go back. I added 11 here, but I really shouldn't have done that. I should have added 9 instead, because cosine was originally, I'm going to draw a quick sketch here. You know, our cosine curve was originally here. This was originally 0, 2. So I didn't need to add 11 to it. I needed to add 9 because I needed this point to be at 432, 11, which means I needed to add 432 here, move it over 432, and move this up 9. So that was my mistake. Let's go back, and these mistakes do occur even for when you have software here where things move a little bit slower than you want it to. For you as well, that you know, if you do this, you need to do a check on this. You can't just assume that it's always going to be correct the first time every time. Just do a bit of a sanity check on yourself and for the problem as well. So here we're going to hit trace, and when you hit 432, this time it should give you a maximum point at 11. Now let's check another point here, which says that the minimum or the low tide has to occur at 804 minutes since midnight and is 7 feet. So we hit trace, and so now we can be very confident that this is in fact the correct function. This is in fact the correct function. And I'm going to erase some of this stuff up here so that we can solve the next part of the problems. And again, I'll point out to you why, you know, once we have the function, the rest of it is pretty easy. At what time does the first low tide occur? First low tide. First low tide. First low tide. So we're going to look for first minimum on our graph. In other words, if we look at the graph, we want this point right here. Okay, we want that point right there because that's the first time that low tide occurred. This axis right here is midnight. We want to see where the first low tide occurs. So I'm going to move it back a little bit just to give myself some room here. Give myself just a little bit of room here to operate it better. And I'm just going to use my calculator to find this minimum here. I know the answer should be 7 for the y value. I just don't know what the x value is. So once my calculator's done the work, you can go to second, calc, find ourselves the minimum, which is the third item on the list. Well, the left bound, well, it's approximately 0. Okay, and the right bound, well, we'll move it a little bit over past the minimum. And we're going to hit enter, move it back. Hit enter here. And that's about 60 minutes since midnight. So that's the answer is, 60 minutes since midnight. So that's 1 o'clock a.m. Okay. Next question. It asks us, what was the approximate depth of the water at 4 a.m. and 9 a.m.? So at 4 a.m., that's really converting that to minutes since midnight. That's 4 hours. So that's 4 times 60. So that's 240 minutes since midnight. So we can just go to our graph, hit trace, and type in 240. That gives us an answer of approximately 8.90 feet. So our answer is approximately 8.90 feet. And how about 9 a.m.? 9 a.m. Well, that's not too difficult to do either. For 9 a.m., that's 9 times 60, or 540 minutes since midnight. So we can go back into here. 540. And that says about 10.224, or we'll go around to the nearest hundredth here. That's about 10.22 feet. And one last problem that we're asked: what is the first time the water is 9 feet deep? 9 feet deep. So in this case, we need to find the time. We're given the depth, and we're asked to find the time. So we're going to find the intersection here. So I'm going to type this in. I'm going to say, when was it 9 feet deep? Well, we'll hit the graph here. 9 feet deep hits the graph of the wave. Okay. So in other words, the water depth starts low, then it goes up, then it goes down, up and down again, over and over again. It's going to hit 9 feet once, twice, and a few more times down here. But we want to know this point right here. When is the first time that it hits 9 feet deep? So we can find the intersection. Second, calc. Intersection is our fifth item here. First curve, that's good. Second curve, that's good. And we want to move the guess over. We want to move this as close to the intersection as we can to get the best approximation from our TI-83 graphing calculator. Hit enter. And it's about 246 seconds since midnight. So part C, this is 246 minutes, since midnight. And let's convert that. 240 divided by 60 is 4. And then you have the 6 minutes left over. So it's approximately 4:06 a.m. as our final answer there. And so just to recap here what's going on, one of the things in this problem what we did here was use the basic information in the problem here to find the amplitude and the period and to create a function. And we actually used the cosine function for this